Hello, my name is Aydın, and today I will be presenting the low-grade colonial segmentation project, which is my capstone project of upskill machine learning program. Here is a table of contents. First of all, I want to talk about my journey and what I have done so far. And I wanted to explain my capstone project, what I have done. Then I want to talk about what upskill has given me. Here is my journey. I graduated from the computer engineering undergraduate program in 2019, and within the same year, I got my first job as an artificial intelligence intern. And then I realized that I want to move forward in this area. And in 2021, I studied MicroMaster in artificial intelligence. I have done I have had an interest in medicine since high school, especially in neuroscience. Since I want to integrate these two files together, I started studying micromaster in neural engineering with artificial intelligence, and I'm still studying in both programs. Then in 2021, I started working as a graduate research student in artificial intelligence for neuroscience, and my research area includes uh, multiple sclerosis, dementia, and traumatic brain injury, and I'm still working on them. Finally, I had an opportunity to participate in machine learning program organized by Upschool in 2022, and I'm here to present my capstone project. I would like to talk about what my capstone project is about and what the main problem is before what I did in the project. What is low-grade glomia? And low-grade glomia is type of brain tumor is classified as grade 2 and 3 tumor. It arises from the supporting cells of the brain called glial cells. They are generally benign, but can cause significant neurological symptoms as they grow and put pressure on the surrounding brain tissue. They are most common in adults, but can also occur in children. These tumors are typically treated with surgery, radiation therapy, or a combination of both. Such, a, such as the problem why deep learning should be used. Deep learning allows for the accurate identification of tumor boundaries in MRI scans. Without the use of deep learning, segmentation of low-grade gliomas can be difficult and time-consuming. Also, segmentation of low-grade glioma can be challenging due to the similarity in appearance to surrounding brain tissue. Traditional methods may not be as accurate as deep learning, leading to potential misdiagnosis and improper treatment. Here is an example of what low-grade glioma tumor looks like on brain MRI images. And these images belong to a 24-year-old who developed focal seizures affecting the left side of his body. And you can see that the red area indicates the tumor location. So let's move on what I did in this project. The data of this project is obtained from the Cancer Imaging Archive and Kaggle, and the dataset contains brain MRI images with manual play abnormality segmentation masks. They correspond to 110 patients, and the CSV dataset has 110 rows and 18 columns. However, using only the patient column from this, you can see here, and the final data frame is created with the brain MRI image paths in here, and the mask images paths in here, and the information on whether the tumor is in the image. And this is the final data set. The visualization part takes place into the two parts. The first part involves displaying the distribution in different ways, and the second part involves the visualization of brain MRI images in different ways. So this data shows the distribution of images grouped by diagnosis, and the data is split into the two groups, positive and negative. And the positive group contains 2,556 images, which percentage represents 65.05% of the total images. And the negative group contains 1,373 images representing 34.95% of the total images. In total, there are 3,929 images in the dataset. The diagram shows the distribution of images grouped by patient and diagnosis. And both distribution, we understood that they indicate there are more positive images than negative images. So data augmentation should be used to get better results from the modeling part. In the second visualization part, I use different color map, which is the hot color map. I want to explain first why hot color map is important for medical imaging. It can effectively highlight different tissue types in the brain based on the MRI intensities. And hot color map, low intensity values to dark colors, which are black, and high intensity values to bright colors, which are red, yellow, and white. And it helps to distinguish different structure in the brain, such as gray matter and white matter. And also, hot color map is also useful in differentiating between healthy and abnormal tissue, such as tumors. And here's an example of what I did in this project. And this diagram shows the representation of different positive and negative images under two different color scales, original color and hot color map. Positive images using a hot color map shows where the tumor is more black or more white. You can see that in here, this area is more black than other areas, so we can say that there is a tumor in here. And this area is more black than other areas, so we can say that there is a tumor. Or this area is more white than other areas, so we can say that there is a tumor in here. So here is another example with original colors, and the diagram shows a brain MRI image, which is here, and a segmented mask of this MRI image, and the segmentation mask on this brain MRI image. As I have mentioned before, the data augmentation should be used for this data, and the data augmentation part, the augmentation library used because of its wide range of image segmentation techniques that can be applied to medical images, and it allows for the easy compression of multiple augmentation together. And the techniques that I use, one of the three different augmentation, which are elastic information grid and optical distortion. And apart from these, eyes brightness, contrast changes, and random rotation, etc. And here are the example of the augmented brain MRI. They're here, and the mask images, and they are here. In the modeling part, first of all, I want to talk about hardware requirements for this project. I use the PyTorch instead of the TensorFlow to work with for complex tasks, which is the segmentation and augmentation library. And PyTorch has built-in support for dynamic computational graphs, which can be useful for segmentation tasks, and where the model needs to adapt to different inputs and input shapes and styles. So in here, I want to explain which models that I use for this project. I use the three different model architecture. The first one is the unit, which is a specific type of the fully connected uh, network that is designed for biomedical image segmentation. And the second one is the feature pyramid network, which is a type of deep neural network architecture that is designed for object detection and semantic segmentation. And the third one is the res unit, which is a combination of the unit and the resnet. And this is the type of the CNN and that use residual connection between layers allowed to the network. Here are the model architectures that I use in the modeling part. And the most important thing is here upsampling and downsampling layers. You can see in here, in here, and here. Upsampling layer increases the resolution by adding more pixels, while downsampling layer decreases the resolution by removing pixels. Um, in the deep learning, upsampling is often used in the decoder part of network architecture, and such as in the segmentation task. And downsampling is used in the decoder encoder part of network to reduce the computational cost. Mm, as you see, I use a pre-trained model in res unit model architecture, and also I use the dice coefficient metric and loss. In the evaluation part, I want to show you the evaluation of the model architectures on training and validation data. The first two models architecture exceed 80%, you can see in here. And the third model architecture exceeds 90% in here. For the evaluation of the model architecture on test data, it was concluded the mean dice value of the unit model architecture on the test data was 83%. For feature forming network is 78%, and res unit 89%. Here in an example where test data is taken randomly, and you can see how compatible the real mask is here and the model predicting mask is here. And this is the evaluation of the prediction and ground truth mask on the brain images. And you can see that the red area, which is here, indicates the prediction mask, and green areas, which here indicate the real mask. And in the result, the res unit model has been more successful. This is the end of my presentation. From here now, I will talk about what upskill has given me. The three most important things I gained during the course skills were resilience, self-compassion, and time management. The first issue is the resilience. Whatever you do, never stop. I believe this more now. I am a person who doesn't like to give up. And up school pushed me harder and showed me that I should pass this on the other people. And another thing is self-compassion. I criticize myself badly when I make a mistake. In this regard, up school showed me how far I have come. If I review what I have shared on the timeline, keeping a journal of the things I do every day has helped me with this. Other issues, time management, and having a separate deadline each week inevitably encourages us. I have now made it a working principle. And teamwork, sisterhood, communication, strong communication are the things that make upskill the strongest. As a single person, we may not be able to raise awareness, but I know we can do anything as a group. I love this quote. Love yourself, appreciate yourself, see the good in you, and respect yourself, written by Betty Shabazz. I truly believe in this quote, and I know that I will be this way from now on. And finally, here are the resources that I use in the project. Thank you for listening to me. And I would also like to thank the Upschool family for giving us such an opportunity.